Example 9. We are given the function f of x is a piecewise function, and we want to determine whether the limit of the function f of x when x approaches to 4 exists. We need to calculate the limit of the function f of x when x approaches to the 4 on the right side and 4 on the left hand side. When x approaches to 4 on the right hand side, the function f of x is square root of x minus 4. And when x approaches to 4 on the left hand side, the function f of x is 8 minus 2x. Then we just go ahead and plug in 4 into the function. So we get 0, and we have 8 minus 2 times 4, and it's also equal to 0. So what we conclude is that the limit of f of x when x approaches to 4 is 0, and it exists. Example number 10, we want to show that the limit of the function, the radius integer function, when x approaches to 3 does not exist. The radius integer function has the double bracket and is defined as the largest integer that is less than or equal to x. So first of all, let's record the integer. Integer are 0, plus minus 1, plus minus 2, plus minus 3, and so on. If we have 1.5 or 1.6, we do not have that as an integer. They are not the integer. Because we are finding the limit approach to 3, so I want to make the graph when the function are around 3. So I want to make the graph in the interval from 2 to 4. Okay, it's better we can make the number line. Okay, so we have this is like 0, 1, 2, 3, 4, and so on. If x equal to 2, then the largest integer that is less than or equal to 2 is 2. And if x is 2.1, 2.1 is right here, right? So 2.1, then the number that less than 2.1 are the one in the pink shaded. Okay, so we will pick the radius integer, so that will be 2. If x equal to 2.9, then the largest integer that less than or equal to 2.9 is the shaded in the pink color, and the 2 is the largest integer that less than or equal to 2.9. If x equal to 3, 3 is an integer and it is equal to itself, so it could be 3. If x equal to 3.1 or 3.9, 3.1 or 3.9, the integer that less than 3.1 or 3.9 is 3. And if x equal to 4, the output will be 4. If you want to make the graph for this, then we have 2, 2, 2.1, 2, until we have 3. So 2.9, 2. And when we have 3, the y will be, the output will be 3. And when we have 4, the output will be 4. So if you continue from this, you're gonna have like a step, like a stair, like this. and so on. Okay. Now we need to calculate the limit of that function when x approaches to 3 on the right side, and limit of that function when x approaches to the 3 on the left hand side. So this is 3 plus minus and 3 plus, right? So when we have 3 minus, we will get 2, and when we have x approach to 3 on the right side, we got 3. So the limit of the radius integer function does not exist because they are not equal of each other. So now let's look at the graph to verify our result. So we have 3 is right here and it is right here. So if we approach from the right side, the answer will be 3 for the f of x. But when we approach to the left hand side on the function of 3, we have the answer will be 2. It's approach to 2. That's why the limit of the radius integer function when x approaches to 3 does not exist.